Good morning, everybody. So this actually will be the very last video that I will be creating this year. It is the key to the Unit 8 review. And again, you can skip through and see some explanations on anything that you need to see explanations for. But you will be getting your test on Friday, and it is due on Tuesday the 19th. Okay, as soon as you get that test done, you are done with Algebra 2. Okay, so get that done. Okay, don't linger around. Make me email 1,000 times. Okay, so here we go. Throughout this review and the test, you will need possibly two formulas, either compound or exponential growth or decay, or compound interest. All right, so we use compound interest when you see the word compounded. If it doesn't say anything about compounded, then you're using that other formula. All right, so here we go. Let's put 1500. You guys can read. I'm just going to go through how to do this. So this 2500 is the A value. That's what we end up with. 1500 is the principal amount. 1 plus the rate as a decimal over the number of times compounded. Compounded quarterly means 4. To the number of times compounded times t. That's what we're looking for. So when we're solving this, we're not going to be able to multiply this because order of operations, I have to take this to a power, and I don't know what that power is. We can go ahead and simplify that number. Okay, so that number gives us 1.0067 to the 4t power. So the next step, again, we cannot multiply these two because I don't know what this power is. So what I'm going to have to do now is divide by 1500. And when I get and divide that by 1500, I end up with 1.67 approximately. All right, now how do I solve for an unknown exponent? Yes, convert to a logarithm. Log base 0.0067 of 1.67 equals 4t. So we use a common log formula. Equals 4t. So we'll go ahead and calculate that. So this gives us 76.796 equals 4t, and then we divide by 4. And what I end up with is actually 19.2. And based off of this question, it would have to take 19 years, and actually a little bit more than 19 years to get 2500. Okay, expressed in common log form. The 7 goes to the bottom. Remember, these are two separate logarithms, so it is letter C, log 57 over log of 7. That's common log. All right, next one, convert to a logarithm. Log base 5 of 127 equals 3x minus 1. So common log, log of 127 over the log of 5 equals our exponent. Calculate that value. This gives us 3.01 equals 3x minus 1. And then we can simply add 1 and divide by 3. And that does give us 1.337. So again, add 1, divide by 3. This is a simple conversion. Which one is the proper conversion? This is always equal to the exponent. There's only one of them that does that. That is letter D. Logarithms equal an exponent. All right, once again, we're going to isolate this base. So we're going to subtract 3 from both sides. So I get 4 to the 2x equals 32. Convert to a logarithm. Log base 4 of 32 equals 2x. Use a common log to calculate that. Log of 32 divided by the log of 4 equals 2x. Okay, now this does give us 2.5 equals 2x. And then when we divide by 2, I get 1.25. And as a fraction, if you use your calculator, as a fraction, that's 5/4. Whoops, so the answer is A. Which of these makes this statement true? Well, if we convert to exponential form, it's 16 to the 3 halves is equal to x. And you can just type that in, but make sure for those of you with the older calculator, you put that in parentheses. So the answer is 64. 64. Okay, solving the equation. Step 1 is to condense to one logarithm. So I end up with log base 6. I have to multiply, okay, that condenses to multiplication. Little side problem here, x minus 8 times x plus 8 is x squared minus 8x plus 8x minus 64. So that gives us log base 6 of x squared minus 64 equals 2. Now we'll convert to exponential. So logarithmic equations convert to exponential equations. Exponentials convert to logarithmic. So let's convert it to an exponent. So I end up with 6 squared equals x squared minus 64. I will add 60, well this is 36. 36, add 64, you get 100 equals x squared. Technically, you should get plus or minus 10 when I take the square root of both sides. However, you cannot plug in a negative 10 into here because you get a negative. So the answer is just 10. 10, 10. All right, which one makes this equation true? So this one, you know, you're not going to be able to plug in values if you are doing that previously. You're going to have to be able to know how to solve this. So first step would be to divide by 16 because we need to isolate this radical. So 64 divided by 16 is 4. So I get 4 equals e to the 3t. Now to solve for the unknown exponent, I convert to a logarithm. Log base e of 4 equals the exponent. What does log base e equal? Yes, natural log. So I have natural log of 4 equals 3t. Then I would divide by 3. So I am looking for natural log of 4 divided by 3. Okay, so you can actually calculate that number, but that's how we would do that if we don't have the calculation key. Okay, this one is a condensing. Condensing, remember numbers in front are exponents. So that comes up, that comes up. Addition means multiplication. Subtraction means division. So these two should be in the denominators. So I do have, for now, I have a log base 3 of x to the 5th plus log base 3 of y to the 4th minus log base 3 of 9 minus log base 3 of 2. Okay, so these two should be in the numerator. Actually, let me highlight something different here. These two should be in the numerator. These two should be in a denominator. Now, I don't see a 9 and a 2 separate because when I put those in the numerator and denominator, I get log base 3 of x to the 5th, y to the 4th, and then a 9 and a 2. Well, what happens with that 9 and the 2 is since they're both in the denominator, we're multiplying those. So you do actually get 18. So the answer is B, log base 3 of x to the 5th, y to the 4th over 18. This one is expansion. Okay, so how many terms do we have? 1, 2, 3. So we should have 3 logarithms. I can automatically assume it's this one because that's the only one that has 3 logarithms. But it's natural log of 3. Those are being multiplied, so those expand to multiplication. This is in the denominator, so that expands into subtraction. And this had a exponent, so that exponent drops to the front, and that's where we get this one. So the answer is C. Okay, Mary puts $1,000 in an account, blah, 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 blah. What we do not see is the word compounded. So this is going to be a exponential growth. We are using A equals P times 1 plus R to the T power. So Mary's putting $1,000, that's the principal. It's earning 3% annual interest, so that is 0.03. I'm looking for T, and I want to end up with $2,000. Just notice I put 100 in there. Okay, So basically I have 2,000 equals 1,000 times 1.03 to the t power. So first step, again, you may not multiply these because that goes against the order of operations. So we first need to divide by 1,000. So I end up with 2 equals 1.03 to the t power. Now how do I solve that? I convert to a logarithm. Log base 1.03 of 2 equals the exponent. So this is log of 2 over the log of 1.03. So I take the log of 2 divided by the log of 1.03. And I end up with, oh, wow. In order for her to double her money, she is going to have to keep that in an account for 23 plus years. Woo, that's a long time. Okay, so convert to logarithmic form. Remember, logarithms equal the exponent. What's the exponent? X. So it's log base 5 of y equals x. That's it. Solve the equation. We're going to condense to one logarithm, which once again, it's addition, so that condenses to multiplication. X times x plus 3 equals log base 2 of 4. So this is log base 2 of x squared plus 3x equals log base 2 of 4. Okay, it's 1 to 1. When it's 1 to 1, those can drop. So I have x squared plus 3x equals 4. Gonna have to set it equal to 0. Factor. And solve. So can I plug in -4? No, these cannot be negatives. So that one is out. The answer is just 1. Okay, I'm going to point out again the difference between this one and back up here to number, where was it? There it is, number 7. Okay, again, this one we cannot just drop the logarithms because I don't have a logarithm over here. So I had to condense and convert. But when it's 1 to 1, it's a nice condense and drop. All right, so solving this equation, you got the natural log of 7x equals 5. So how do I solve logarithmic equations? We need to convert to exponential form. Natural log means log base e. So this is e to the 5th equals 7x. Again, using our calculator, e to the 5th is about 148.4 equals 7x. So I divide by 7, and I end up with 21.2. So x is 21.2. And last but not least, one more condensed form. Okay, so I have an exponent and an exponent. Okay, so I have log base 2 of 5 squared plus log base 2 of 4 to the 1/4 minus log base 2 of 5. Well, let's go ahead and just simplify these. These are just numbers. What's 5 to the 2nd and what's 5 to the, just notice I put a to the 1/2 here, or 4 to the 1/2, 4 to the 1/2, 4 to the 1/2. Okay, so I have log base 2 of 25 plus log base 2 of 2 minus log base 2 of 5. Okay, so now I can combine it to one logarithm. 25 and 2 get multiplied. The 5 gets divided. So log base 2 of 25 times 2 over 5. That gives us log base 2 of 25. Oh, wait. Hold on, I messed up somewhere. Oh, whoops. Okay, here we go. That was supposed to be a 25. And that wasn't right anyway. It was supposed to be 10, the way that I did it. Okay, we'll fix it, we'll fix it, we'll fix it. All right, so we got 25, 25. So what does that give us? 2, log base 2 of 2. Log base 2 of 2. Okay, guys, that is it. Please email me if you have any questions or need to go over anything live. Please, please, please set up something with me. All right. Okay, take care, take care, take care.